Hey guys, welcome to a new video. In this video, we will discuss a new problem of the day, which is distribute candies in a binary tree. So let's see the problem statement first. Given a binary tree with n nodes, in which each node value represents number of candies present at that node. In one move, one may choose two adjacent node and move only one candy from one node to other. So the move can be from parents to child or from child node to parent node. And our task is to find the number of moves required such that every node has exactly one candy. There is a note that the test cases are framed such that it is always possible to achieve a configuration in which every node has exactly one candy after some moves. So basically it is saying if we perform some operation for every test cases taken in this problem, every node in our given tree will contain at least one candy. This is how all the test cases are framed. So I hope you understand the problem statement given. Basically, we have to find the number of steps required to distribute candies among all the nodes present in our given tree. So let's take the first example. Here the tree has three nodes. This is the root node and these are the leaf nodes. So we can see our root node contains three candies. But our requirement of the problem is every node will contain at most one candy. So our root node will distribute one of the candy to the left child and the other candy to the right child. So our root node will be left with a single candy, and hence you can see after performing such operations all the three nodes contain exactly one candy. So the number of steps required to perform these operations are: to distribute a candy from root to left, we have performed one step, and to distribute to the right, we have performed another step. So the total number of moves calculated is 2, and thus our output is 2. So in the same way, we will see the next example and we will discuss how to approach this problem. So this is our given example. So the tree contains one root node and two leaf nodes. So we can see our left node contains three candies. So it has to distribute some number of candies to the root node, because at most a node can contain only one candy. So it can't contain all the three candies, right? So that's why it will distribute some candies to its root node. And also according to the problem, it can't distribute or share the candies to this node. The distribution can only be done between two adjacent nodes. So this is not possible. So this left node will give two candies to the root node, and now you can see our root node has two candies, but our right node doesn't contain any candy. So as we have to distribute at least one candy to each of the node, our root node will share a candy with its right node. So the number of steps in the right side of the tree is 1, and the number of steps in the left side of the tree is 2 for sharing two chocolates. So these are the number of steps, that is a number of move to share a candy in the right part of the tree was 1, and the number of moves performed in the left part of the tree was 2, because in the question it is given, you can see this, in one move one may choose two adjacent nodes and move only one candy from one node to another. So sharing two candies at one go is not possible. That is why we need two steps in our left part of the tree to share two candies. And for the transaction of candy in the right part, there was another move. So all total, the steps were 3. 2 in the left, 1 in the right. Total, we got 3 steps. So now let's discuss how we will solve this problem. To solve this problem, we will follow the bottom-up approach. We will start calculating from the bottom. We will start calculating the number of steps from the bottom till our root node. So basically, we will solve this problem using recursion. And even if you do not have any prior knowledge to the tree concept, it is not required in this problem actually. So using simple recursion technique, we can solve this problem. So what we will do, this is our given tree. The root node is 0. The left child has a value of 3 and the right child has value of 0, and we can consider the leaf nodes as null. Now in every steps we will calculate the number of moves required to distribute the chocolates. When there is a null node, that means there is no need to distribute chocolate to these nodes. These are the leaf nodes, right? There is no need to distribute chocolates to these 4 nodes. We have to distribute chocolates among these 3 nodes. So it will return 0. This will return 0. So our left will return 0 and our right will also return 0. If we encounter a node which has a value null, we will return 0. So here we will calculate the total number of steps. So we can see the value returned from the left child is 0 and the value from the right child is also 0. So the number of steps will be 0, because there is no need to distribute chocolates to these nodes. So the steps will be anyway 0 only. So in this case, the number of steps are 0. And now if you consider the right subtree, these two nodes will again return 0 because these are null nodes and the steps here will be 0. So basically you can relate this with a recursion tree, and every time we have to return a value. So our left node and right node has returned a value 0. So the total value or the number of steps is 0 till now. And now these two nodes, that is the left node which has a value of 3 currently and 0 as a right node, will return some value to its root node, right? So what will be the value? So for each recursion call, the value returned will be left plus right plus the current value which is stored in the node minus 1. So now the question arises why we have subtracted the current value by minus 1. This is because we have to keep one candy for this node, for the current node itself. So we have subtracted 1 from the current value and the rest of the candies will be distributed to its root node. So that is the reason we have subtracted 1 from the current value. So you can see if this value is returned, so the left is 0 and the right is 0, the current value is 3 and 3 minus 1 is 2. So it will return 2 to its caller function, and similarly our right child will return something. So in this case also the left was 0 and the right was 0. The current value is also 0. So 0, and we have to subtract it by minus 1 because it need one chocolate, right? So the total value becomes minus 1. So it will return minus 1. So this minus 1 indicates that our child node do not contain any chocolate. So it will take a chocolate from its root node. And here you can see the value is positive. That means our child node will give some candies to our parent or root node. But according to the question, we have to count the number of steps required to distribute this number of chocolates. So here we have written the number of chocolates. That is, this node will return 2 chocolate and our right node will accept 1 chocolate from a root node. But to calculate the total number of steps, we will add the ABS value of the left tree with the ABS value of the right tree. Our left tree is returning 2. That means 2 steps are required to send 2 chocolates. That's why we are adding 2 to our steps. And in the right subtree, you can see the value is minus 1. But steps cannot be negative, right? So that's why we have taken the ABS values. So we will take the absolute value of minus 1, that is 1, and we will get total 3 step count. So just for a quick recap, when the value of the root node is null, we will return 0. For each function call, we will be returning some values. The value will be calculated using this formula. This is the value of total number of chocolates which has to be distributed. This is not the step count, right? Because we can get a negative number from this, but a step cannot be negative. So we will be calculating the step count separately. We will add up the absolute values returned from the left child and the right child, and by this way we will get our expected output. So we have seen using simple recursive technique how to solve this problem. Now let's talk about the space and time complexity of the problem. So as because we are using recursion technique, it will use stack to store the results, and the size of the stack data structure will be equal to the height of the given tree. So if h is considered as the height of the given tree, so our space complexity will be big of h. And if we talk about the time complexity, we have to iterate through all the nodes present in our tree because we have to distribute chocolate to each of the node. So if there are n nodes in our tree, we have to traverse for n number of times, and thus the time complexity will be big of n. So I hope by now everything is clear about this problem. So let's quickly get into the code. So we have to calculate total number of steps. So let's declare a variable in steps. Now as we have discussed, to calculate these steps, we need to perform recursion. So we will call a helper method. In the helper method, we will pass our root node, and after the recursion, we will simply return our step count, right? This is all about the program. And now let's just create our helper method. It will accept the root node. So I hope you remember our base case. That is, if the value of the root node is null, we will simply return 0. So let's check if root is equals to null, we have to return 0, and else we will recursively call this function for our left child and the right child as well. So for that, let's create two variables for left l, and we will call the function recursively, and we will pass the left node of the tree, that is root dot left, and int right r equals to helper, we will pass the right node. that is root dot right. So they have already provided us a node class where we have a left node and the right node and the data of this node. So we will traverse the left side of the tree, and each time it will return some value which will be stored in our variable L. This value is nothing but the number of candies which has to be shared. And accordingly in the variable R we will store the values returned by the right subtrees. For each function call we will calculate our step. So step will be equals to step plus the ABS value of the left subtree which is stored in L and the values returned by the right subtree. So for each call we have calculated number of steps. Now we have to return a value which we have already discussed, that is L plus R plus the current value which is stored in root dot data, and we will subtract 1 from the present value. So this value will be returned for each function call, and accordingly we will calculate the steps. All these things are already been discussed in detail, so I hope there is no confusion. And yes, this is all about the program, but there is a mistake. So as we are calculating total steps count outside the distribute candy function, we have to initiate our step variable globally. So let's do it. And also we are using it in a static function, so we have to initiate it like static int. So we have declared our step variable, and let's initiate it with the value of 0. And now our code is looking fine. Let's compile and run our code. So compilation is completed. Let's submit our code. So our code has passed all the possible test cases. And in this video, we have discussed how we will approach to this problem. We have also discussed about the space and time complexity of the program. And I hope I have cleared all the doubts by this video. So if you found this video helpful, please like, share and subscribe my channel. And if there is any confusion in the video, don't hesitate to reach out in the comment section. And yeah, let's meet tomorrow with a new video. Till then, happy coding.